Wish you could use it on a test. Okay. So are there any questions about this?
Is the test going to be in the lab room, or are we gonna
It's
have
going to
it
be
in the room?
somewhere else, yeah.
Somewhere else, okay.
Yeah, and I'm still working on that. Thanks for
Okay.
reminding me. Yeah. The last resort is the lab, but those stools get hurt on my butt sitting on them, so. Okay. So, anything else? That's the game plan. I'm excited. So, before we start this topic with the calculators, I want to remind you when we talked about compounds, abbreviation CPD, a type of pure substance, we said there's two types of compounds. There are molecular, otherwise known as covalent. And what's the other one? What's the other type of compound?
Ionic.
Ionic, very good. Ionic CPD. So I mention this because of this fact. We said that we call molecular, a repeating unit of a molecular compound, we said we call those molecules. That's their name. Okay, do you remember what the repeating unit of an ionic compound is called? I kind of teased because of its abbreviation.
FU.
It is formula unit, it is FU. That's its name. Like if you have and the thing is, like, of course, an example of the ionic compound we've been talking about is table salt, NaCl. And if you isolate a repeating unit, it's like kind of, if in solid state, it's in a crystalline lattice structure. So it's kind of connected, okay? So remember that. That's kind of one of the things will come up today. Now this topic students usually do pretty well on. Because this is Unit 3. In Unit 2, we talked about how do you know how much an atom weighs. Well, you know how much an atom weighs if you have the periodic table, right? If you have a periodic table, you can look at that decimal number. That's how much an atom weighs in AMUs. Well, let's just say that atom is part of a molecule. If you want to know how much the whole molecule weighs, you add up how much each individual atoms weigh, right? Okay? So molecular weight must be talking about the mass of a molecule. So you must know that that's a molecular or covalent compound, right? Okay. So all you got to do is add together. You have to have a periodic table, right? But you just have to sum up how much the mass of all the individual atoms are. And then remember, we said that that decimal number is, atoms are very light. So that's a new mass. It's called AMUs, atomic mass units. Okay, good. Well, this slide is very similar, but remember you guys told me the repeating unit of an ionic compound is a formula unit. Well, if you have an ionic compound and you want to know, for instance, how much a repeating unit weighs, like NaCl, that would be a formula weight. Okay, so instead of, we have molecular weights, the weight of a molecule, we have formula weights, the weight of a formula unit. That's it. But it's done the same way. Okay? How do you do it? If it's for sodium chloride, you know, you go to the periodic table, look at the decimal number for sodium, you go to the periodic table, look at the decimal number for chlorine, you add them together. So, my calculator died, so I'm thinking, what kind of calculator do I want next? And I like those TI-30s. I don't know. We'll have to see.
Expensive.
Are they expensive, the TI-30s?
At least they were expensive here. I guess I bought mine at the school.
I might try Amazon.
Yeah, they were expensive here.
Well, thanks for the warning.
Yeah, I paid, I think, $100 for the TI-85 or 84.
Yeah, the TI-85, though, you can't use on your tests. Okay. So this is a little bit of grammatics. Actually, on your test, for extra credit, I said you can write the empirical formula. Okay. Write the empirical formula for the following compounds. We're going to talk about that probably on Monday. And that's kind of where this enters in. A molecular weight is also a formula weight, but a formula weight is not necessarily a molecular weight, because a formula is like a reduced version of what it really is, possibly, empirical formula. Okay, so that was kind of a little bit aside. So let's do one. not too bad. Hydrazine, of course you wouldn't have to name that, but it's got 2 nitrogens and 4 hydrogens. It is a molecular compound. Remember I said look for the metal. Nitrogen's not a metal. And I said hydrogen for purposes of what you're going to do on your test. Element number 2. Element number 2. If I give you a formula, is it a ionic compound or molecular compound? Okay, hydrogen is a nonmetal. Okay, so here we go. I think I just kind of knock it out. Those builds are annoying, aren't they? Okay. So you see 2 things added together. The first thing is the mass brought by nitrogen. The second term is the mass brought by hydrogen. So the decimal number for nitrogen is 14.01. Of course, that's atomic mass units, or AMUs. There are 2 of them. Plus, there are 4 hydrogens, 4 times the decimal number for hydrogen, which if you do enough of these, hydrogen's one of those you're going to start to remember, just memorize. The decimal number for hydrogen, 1.008 AMUs. Now notice that I've rounded to 2 decimals here in my answer, and actually we are adding terms, okay? And if we're multiplying and then adding, but if you're adding terms, you have to round according to decimals, and that actually is correct. The thing about the multiplication we're doing here is the 2 and 4 for the nitrogen atoms and the hydrogen atoms, actually those are exact quantities. There's no uncertainty in there, so they don't bring uncertainty into the problem. Okay, let's do another one. The only difference here is that it's not a molecular weight, it's a formula weight. Okay, why? Because it's an ionic compound. Calcium is if you're like me, you got to find it. Calcium is a metal. Remember, on Thursday's test, you should have plenty of time, 2 hours. Take your time. Okay, so here we go. Kind of a similar thing here. We have 3 terms that are added together. The first term is for the calcium. We have 1 calcium atom. Its decimal number is 40.008 AMUs. Plus, we have 2 nitrogen atoms. So this is where I'm counting on, I think you guys correctly interpret the formula. Here's where I'm counting on the fact that since I have this 2 out here, that means I have 2 nitrogens, and you guys would tell me 6 oxygens. Okay, so there's my 2 nitrogens and my 6 oxygens right there. So I have 3 elements to account for. Okay, not too bad. One of the things when we're doing, when we're doing this sort of problem, we forget to include the units. So do not forget the units. Okay, these problems, let's see. Oh, yep, oh, so no, not molar mass, sorry. I was thinking it was number 9, but not quite. This is molecular weight and formula weight. But units are going to be AMUs. Any questions about that? Yeah, pretty good. Okay. Yes. So this will be due for Monday. Now, instead of pulling them up on the internet, actually I have them here. Show you what I mean. Okay. So this is a screenshot of 83 and 84 from your textbook. Of course, 83, it's blue, it's odd, not as in strange, but odd number, so you can get the answers in the back of the book. Okay, so my hints down here are use the periodic table. Okay, feel free to use, I said the abbreviated method, but that doesn't necessarily apply. But the thing in red here does apply. Okay, don't forget to label. Don't forget to label your answer to get full credit. And then I did one down there for you. Notice, I guess it is a little abbreviated. Does anybody see? This is for the first one. The first one is HNO3 in blue down there. Okay. Does anybody see anything different about kind of the ones that we worked just now? I didn't include the AMUs. Yeah. And that's fine. So if you want to, put the AMU there, you can. But where you have to have the AMU is where I have the AMU. No naked numbers for your answers. Okay? So that should be pretty good. You know, if you're feeling overwhelmed and you just want to do a few of these, if you've got extra credit, you know, that's fine. If you're looking for homework points, probably better do these. All right. So, on to something a little bit different. I have some, they remind me of review slides. Does this not look like a review slide? You're like deja vu sort of thing? Yeah. We talked about this in Unit 2, the concept of a mole. Really exciting, right? Concept of a mole came about because atoms are so dang small that if you have a dozen atoms, it's like you can't sink your teeth into that. If you have 6.022 times 10 to the 23rd atoms, then you have something, right? Okay. So a mole of atoms is something you can sink your teeth into. So actually, as you might imagine, we're going to apply that concept of a mole. We're going to scale it up from atoms to molecules, or atoms to formula units. That's it. Concept of a mole. This is another repeat slide. Okay, so a mole is a counted number of particles. After your test on Friday, we'll start talking about chemical reactions. And chemical reactions, you really got to go with particles. You got counted particles. And so the concept of a mole is really important in chemical reactions. If you want to kind of quantitate what's going on in a chemical reaction, you can't go with mass, but you can with moles. So moles are really important. So when we talked about atoms and the elements, we said that if you have a mole of any element, then you have 6.022 times 10 to the 23rd atoms of that element. That's what we said. That's an equivalency statement. 1 mole of atoms is equal to 6.022 times 10 to the 23rd atoms. You can take any equivalency statement and you can make a pair of conversion factors out of them. And actually, you might kind of, if you want to beef up, I know this stuff, feel free to, a lot of you, go back and look at the last problems you did on your Unit 2 exam. And there were these sort of problems. Okay? So, and if it was a little ishy for you in Unit 2, then you have another stab at it. So these can actually be used as conversion factors. So, but like I said, now we've switched gears to compounds from elements or atoms. Okay? So now we're going to talk about a mole of molecules is equal to 6.022 times 10 to the 23rd molecules. So any equality like that we can make to 2 conversion factors, and they're like this. Okay? 1 mole of molecules over 6.022 times 10 to the 23rd molecules, 6.022 times 10 to the 23rd molecules over 1 mole of molecules. Same thing. And this slide is very similar. The only difference here is instead of molecular or covalent compounds, it's ionic compounds. Okay, so these would be formula units. That's the only thing that's different. All right. Well then, also a little bit of deja vu. You know, I'm counting on you remembering stuff we talked about in Unit 2, is this concept of a molar mass. And the concept of a molar mass is basically if you do have 1 mole of those molecules, how much does it weigh in grams? So it's grams per 1 mole of anything. It could be hockey pucks, it could be atoms, it could be molecules. And there are different ways to express molar mass. This is my favorite one if you're using a problem. Okay, this is the one, I call it flat. Okay, a lot of times if you're reading a problem, not working it, but it'll be given in a flat kind of respect. This one actually, anytime you have anything raised to the negative power, that is actually in the denominator. So those are units of molar mass. And we said for the atoms, for the elements, we said that molar mass is that decimal number. So if we pick on carbon, because, let's pick on hydrogen. For hydrogen, okay, it weighs 1.008 AMUs for hydrogen. Okay, we also said for hydrogen, its molar mass, and I think I used this stands for molar mass. Its molar mass is the same number, but it's 1.008 grams of hydrogen per 1 mole of hydrogen. That's its molar mass. It's like a physical property of the elements. Okay? So molar mass, we said, was equivalent to the atomic weight for the atoms, but of course you got to change the units. Well, you know what's coming. So the molar mass for molecules, that's a lot of M's, the molar mass for molecules is numerically equivalent to the molecular weight you just calculated. But of course, units for molecular weight were AMUs, and units for molar mass are grams per mole. Okay. For ionic compounds, we don't talk about molecules. Instead, we talk about formula units, and we calculate a formula weight. And so for ionic compounds, the molar mass will be the same number as the formula weight. Okay, but it will be in units of grams per mole. So we're kind of making that leap, which isn't too much of a leap. So molar mass, just like we used before, since molar mass is in terms, the units, always look at the units. I still have, most science, people in science, or maybe even nursing, will tell you, if you look at the units of anything, that actually, and you're trying to work a problem, that will get you down the road. Units for molar mass are grams per mole, and you can use that as a conversion factor. For instance, we could start with moles. Okay, and get to grams. I'm going to do one more thing up here. I'm going to go ahead and flip the molar mass. I'm going to put mole over gram. That's my molar mass. And this actually we can use if we're trying to go from grams to moles. I hope that's kind of ringing some bells, because that's kind of what we have going on there. Molar mass in purple. Molar mass is the same number as the molecular weight and the formula weight. So for these, it's going to be very similar to what you guys just did. You're going to use the periodic table like for the first one and look up the decimal number for carbon, look up the decimal number for hydrogen, sum it all together. But now, instead of units of AMUs, which was the molecular weight, the units are going to be grams per mole. And we're going to do the same thing for the ionic compound ammonium chloride. So here we go. Now this actually, can't remember what your notes are like, but I'll put this whole thing up here. This is explicit labeling, and actually when I work these problems, I do not work it this way. The title of the next slide for you says something about the abbreviated method of working this, and that's how I work them. So if you want to write this down, you can. But this actually is not how I would come up with the molar mass of C2H6. But with that said, it makes sense. Okay, basically, this is the carbon term. Okay, this is the hydrogen term. For carbon, we have a subscript of 2. Okay, so that means in 1 mole of C2H6, we have 2 moles of carbon. We know from the periodic table that the molar mass for carbon is 12.01 grams per 1 mole. Okay, so that's how that all goes, how it comes from. Switching gears to hydrogen, there are 6 hydrogens. So in 1 mole of the compound, we would have 6 moles of hydrogen atoms. The decimal number for hydrogen is at 1.008 grams per mole. So when the dust finally settles, rounding it to 2 decimals, okay, you'll get a number 30.07, and the units will be grams per mole. And a lot of times, you're not even going to see me write grams of C2H6 per mole of C2H6 grams per mole. So this is the abbreviated way of working that same problem. We have the carbon term, we have the hydrogen term, and I knock out the molar mass at the end. But again, one thing that I do not, I'm kind of sloppy every once in a while in working my chemistry problems, but one of the things I do not do is write a naked number. I'm pretty sure I don't. Actually, now that you mention that, I probably have before. But don't forget your units. So the molar mass, I love saying that, the molar mass for compounds are not too bad, as long as you have a periodic table, okay? Molar mass. It's probably feels very similar to what you just did a few minutes ago, coming up with a molecular weight. But units of molecular weight are AMUs, units of molar mass are grams per mole. All right, so let's do ammonium chloride. So we have a term for the nitrogen, 1 times 14.01. We have term for the hydrogen, plus 4 times 1.008. And we have a term for the chlorine, plus 1 times 35.45. Rounding it to 2 decimals, the molar mass, and using units of grams per mole, the molar mass is 35.49 grams per mole. 53, thank you. He is listening. 53.49 grams per mole. All right, so there, I'm like, oh my goodness, we're going to cover something new and have a test Thursday, blah, blah, blah. But you know what? This stuff, usually students just like, I get it, right? Okay. All right. So for the problems we've worked, a few things. Notice that whether they were the weights or the molar masses, I've rounded to 2 decimals, and that actually was what I was allowed. This is a little side note to here that if you're dealing with something that is light, and basically the only things that's light are these first 4 elements: hydrogen, helium, lithium, beryllium, the lightest of the elements. I say they're light because they're less than 10, okay? And if they're light, then if you can, I would go with 3 decimals. The thing with hydrogen, for instance, for hydrogen, I go with 1.008. For helium, 4.003. Oh, that's right. That's a good password. For lithium, 6.941. And for beryllium, 9.012. No, you don't have to memorize those. When we get to lithium, when we get to boron after beryllium, it's 10.81. So that's how that goes. Things that are heavier, you can actually just go with 2 decimals. Now, there are times with this said that you're using a periodic table that rounds, for instance, hydrogen, instead of 1.008, and I think your periodic table might do this, it's 1.01 grams per mole, or AMUs, instead of 1.008. Just do what you can. On your test, of course, you'll have the 3 decimals for those 4 elements. All right, so notice what I've done here. Do you have to do this?
Yes. This one's for extra credit.
Yeah, no. Assignment for extra credit. Technically, if you're kind of after the assignment points, yeah. Keep your calculator flowing, yeah.
Want to do them now? Or?
No, not now.
We can
This
turn them
is-
in Monday.
Right, turn them in Monday. Yeah. Yeah, I could see why you think we do this class. No, these are to turn in if you want them for extra credit. So what will the units be for this? Sometimes you have to read the question a couple times. What will these units be?
Grams per mole.
Exactly, grams per mole. Some people just love doing these little math problems, right? And, okay, so I go to your Thursday test where the stakes are higher. This matches up with number 9. Number 9 on your outline, calculate the molar mass of blah, blah, blah. Okay? See, we've only been here 30 minutes now. All right. Here we go. So we're okay with the weights, molecular weight, formula weight. We're okay with calculating the molar mass. Now we're going to do what we did with atoms, and we're going to go ahead and use that as a conversion factor. Kind of like I showed you a minute ago. We can go from grams to moles, or we can go from moles to grams. And today I'm not going to go ahead and use Avogadro's number. Today we aren't going to use Avogadro's number, but Monday we will.
Aw.
Okay, so let's work a problem. And so the compound of interest is CHCl3. Okay, sometimes I read a problem a couple of times. So if we were to diagram this, I might do an arrow, how many moles, so I put moles over here. Don't let the thing in brackets throw you off. Remember, I used the brackets before. The thing in brackets may or may not be there. It's implied if it's not there. How many moles is 1.28 grams of chloroform? How many moles of molecules? Okay, we will not use Avogadro's number here. So it looks like we're going to go 1.28 grams to moles. How many moles is 1.28 grams? And then over the arrow, I'm going to put MM stands for molar mass of CHCl3. So it's kind of stepwise. Your first step is to, and you have to show this, calculate MM of CHCl3. Step number 2, use MM to go use MM to get from grams to moles. That's just it. And sometimes students don't take me at my word, and you must show this. For 2 reasons. One is because it's good to show your reasoning behind getting from 1.28 grams of chloroform to moles of chloroform. And the other thing is it can save your butt, because if you your finger slips on adding up the weights and everything for CHCl3, then I can see that and it makes more sense, and you can definitely get most of your credit. All right, so let's do it. The molar mass of CHCl3, we'll have to look up the decimal number for carbon, for hydrogen, and for chlorine. So we take 1 times 12.01, that's the mass of carbon, plus 1 times 1.008, that's for hydrogen, plus 3 times 35.45, that's for chlorine. And so you have to show this, rounding it to 2 sig figs and giving it units of grams per mole. We'd have a whopping 119.37 grams per mole. 119.37 grams per mole. So this is where, if I was working it and on my answer keys, a lot of times I will kind of unpack that, and I will write for this compound, there's 119.37 grams per 1 mole. I go ahead and unpack it, because to me that makes more sense. It's the same thing, right? So now our first term is going to be the grams we want to convert. Just if this is feeling similar, like deja vu, we kind of did this sort of approach before. Okay, I usually put it over 1, so 1.28 grams. Okay. So this is where, if we want grams to cancel, do you see we're going to have to flip? I call it flip the molar mass. If you want grams to cancel, then you better use your molar mass like this. So the first term is 1.28 grams. Again, do I add the CHCl3? Probably not. After your test, when we talk about stoichiometry, we probably are going to have to use it. But if we already know it's just kind of within that one compound. Okay, so grams will cancel. We'll be left with moles. And then don't forget our rules of rounding. Get your fingers ready. Rules of rounding. So how many sig figs do we need to allow? 3. I didn't see many fingers. All right. Thanks. 3 sig figs. Yep. So do you see that actually if we, to give it 3 sig figs, we have to include that 0 there, okay? And the middle, the 0 that's between 1 and 7 is significant, okay? But that's 3 sig figs. Any questions? So it might feel familiar. And like I said, you know, feel free to go back and look at your last problems in Unit 2 exam. And you're going to have some practice at this. All right, let's do another one. One more. So now it's methane. It's CH4. And in this case, we're given moles. we want to get to mass. So it looks like this, right? We're going to go from 0.4444 moles. Okay, we're going to go to grams. And we're going to accomplish that using the molar mass of CH4. So if I would write stepwise, we've got to do the molar mass first and then apply it. It's like a physical property of methane. It's so wonderful. And our first term is going to be 0.4444 moles over 1. So here we go. Here's the molar mass of methane. We take 1 times the mass of carbon, 12.01, plus 4 times the molar mass of hydrogen, 1.008. Round it to 2 decimals. So the molar mass we're going to use is 16.04 grams per mole. So yeah, make sure you show that step and feel free to kind of unpack it, get it ready to use. So the first term is going to be our 0.4444 moles over 1. And then we're going to go ahead and insert our molar mass, but now we don't have to flip it, do we? Because we want moles to cancel. So now we're just going to insert our molar mass. And so in doing that, our moles will cancel, and we'll be left with units of grams. So get your fingers ready. How many sig figs do we need to use? I'm liking it. Very good. 4 sig figs. So I got 7.128 grams of CH4. 7.128 grams. Any questions? Okay. Did you get something different? Uh-oh. Fact check. Did you get the same thing? Okay. Very good. These are like really important problems. The whole being able to take a mass and to know how many moles there are, or to take a moles and know what sort of mass you need to weigh out to get that number of moles. That's very important chemistry, because the concept of particles participating with other particles are important. So this one, okay, will also be due. And let me show you what this one looks like. So I'm skipping the problem, the next problem or whatever. Did I skip a problem?
Yeah.
Okay, we'll do that on Monday with Avogadro's number. But in the meantime, and I pushed these out there already. I'll show you what I have out there. We'll take a look at the screenshot for these. And it looks like this. Okay, so these are the two, and the reason I put the names there might be obvious. We didn't name all those. We named the first one, or sodium chloride. You need to unpack the formula for sodium chloride. I almost hesitate to sign this, not because I feel like it's cruel, but because I do not like that they have thrown in naming covalent compounds. I tried to emphasize that the lab that we did 2 weeks ago was ionic compounds. In ionic compounds, you avoid, like the plague, using the mono, di, tri, tetra, penta. You just do not. The only time you use those in ionic compounds is when hydrogen, when you have like hydrogen thrown in there for your polyatomic ion. So here, finally, you see things like carbon tetrachloride. Okay, and this is just your cross to bear, so to speak. Shouldn't say that. Good Friday. But you're going to have to know that you will never, ever, ever use tetra. You will not use tetra on your exam. Okay? If you need 4 chlorines to balance the cation you're matching it with, you do not use tetra. Okay? I don't know. I'm probably overstating that. But anyway, So there's the formulas for those compounds. And so here are my hints down here. For both of these, you're going to need to knock out the molar mass for those compounds. So this is not for extra credit. This is just for regular credit, okay? For both problem sets, A through D, you're going to have to knock out the molar mass. Okay, you need to show that step to get full credit. And the difference between 47 and 48, if you read it, 47 is going from grams to moles using the molar mass, and 48 is going from moles to grams using the molar mass. And then my little suggestion is there, don't forget that the odd problems like 47, you can see the answers in the back of your book. Okay, so yeah, this sheet and the previous sheet are out there on the Twitter feed. So. Okay, and you guys need to remember how to get to Twitter feed? Are you guys okay with that? If you have internet connection, you don't even have to subscribe to Twitter. You just go Twitter/EA_Snipes_CHM122. It's in my syllabus.
You need to use the SEC website.
Yeah, there's so many different ways to, yeah, you could use the e-companion because it's a rolling feed there. It's not hard to get to the Twitter feed. That's all I have today. Any questions? I know, we covered a lot. We're done early. Dang, what's up with this? So, feel free to, email me if you have any questions, but I think you'll do fine.
Isn't that what Toby has basically, is the US stocks celebrities going